So a quadratic function is a function with a degree of 2. And is the degree the highest exponent or the lowest exponent? Who remembers? The highest. Say it with confidence. Highest. So it's like x squared, the ones that we've been factoring, that's what we're going to be graphing. So our two units, 8 and 9, relate to each other. Now a parabola is the graph of a quadratic. It's not parabola. It is not a disease. Alright, the vertex of a parabola is the highest or lowest point on the graph. And we have two ways that our graph could look. It could look like this, where our vertex is down here. This is called a minimum, because it is your minimum, not minimum, because it is your smallest value. Or it could look like this. And what would this vertex be called? A maximum. Take a point. So parabola has a vertex. It also has solutions. And the solutions are where the graph crosses the x-axis. Or where y equals 0. So your solutions for the one on the left, we have 2. We have one here and here. And we have one here and here. Those are solutions. Are we ready, or do we need a mo? A mo? Okay. Are we ready now? Okay. I shall just keep doodling. Lexi, we almost ready? Alright, so solutions have 3 names. These are very important. They are known as x-intercepts. They are also known as roots. And the last name that they are called by are zeros. So they have 3 names, and I could ask you different ways. I could say, tell me what the x-intercepts are, tell me what the roots are, tell me what the zeros are. And that's where it crosses the x-axis, or where y equals 0. Now, a quadratic can have 2, 1, or no real solutions. Two solutions means it's going to cross the x-axis how many times? Twice. So I'm going to put one at -4, I'm going to put one at +4, and I'm going to put my vertex down here at -6. I'm going to connect those with a U, and the graph of a quadratic is always a U. It's never a V. So make sure you loop it. That is very important because a v is a different function. Ta-da! That's what it looks like if it has two solutions. So if it has one solution, how many times would it cross the x-axis? One time. And that would also end up being our vertex. So when it's one solution, it would be your vertex. And I'm going to make it look like this. And how many times would it cross if it has no real solutions? None. So I'm going to put my vertex at 0, 4, and it's going to open up and be a U. Now your solutions are coordinates, but if you have no solutions, I can't. You just write none. If you have 1, you write it as a coordinate, so this would be 6, 0. And at the top we wrote that we want where y equals 0. Well, y equals 0 here, so we know that's the solution. How many solutions do we have for the blue one? And what are the coordinates of that? Good. I know what you meant. You can also write it in set notation, where you write it as negative 4, 4. Or you write this one as 6. Are we ready to graph? It's super easy. Alright, so when you're graphing, all you have to do is plug into your quadratic. And the one that we're going to start with is called our parent function. Y equals x squared is your parent function. It's the function from which all other functions flow. So let's write that this is the parent function. And normally we would plug in the same values over and over. So this is to plug in negative 2, 1, 0, 1, 2 for x and get your y values. So we're going to write those in our t-table. Now, are we going to plug those in for x, or are we going to plug those in for y? For x, because this is x. So you plug it in right here. What's negative 2 squared? 4. That's your y value. What's negative 1 squared? Good. What's 0 squared? What's 1 squared? And 2 squared is? Now, what do you notice about the y values? They repeat. They're the same, except at what point? 0, 0. So the one that's by itself, the value that doesn't repeat, that's your vertex. So they're going to repeat every single time, and that's how you know you've done your whole parabola. And the one that doesn't repeat is your vertex. So let's plot this. So it says plug in these, and then plot to make your parabola. So we're going to go left 2, up 1, 2, 3, 4. Left 1, up 1, 0, 0, 1, 1, 2, 4. And do I connect these with a U or a V? A U every single time. Any confusion? Are we alive? Every day we're zombies. Alright, so this was y equals x squared, and our x squared was positive, and it opened up. Example 2 is y equals negative x squared. So we're still going to plug in the same values. But But what is going to happen to our output? What are we going to have to do at the end? It's going to make it a what? A negative, because we have a negative right here. So if I do negative 2 squared, what do I get? 4. But with this negative on the outside, that's going to become a negative 4. If I square negative 1, what do I get? But what does this negative turn it into? Awesome. Is 0 going to change? Alright, what's 1 going to become? And what's 2 going to become? Awesome. And which one is our vertex? 0, 0, because it's the one that doesn't repeat. Alright, plot those and graph it. Does everybody's graph look like mine? So when your x squared is positive, it opens which way? Up. And if it's negative, how does it open? Down. Good. And that's going to be the case every single time when we're graphing them. So when you're looking at your function to begin with, always check out x squared. If it's negative, it's going to open down every single time. If you want to write this note down, do that. And then we're going to see what happens when we add stuff to it, because we're not just going to have baby functions every time. Super exciting. We ready? We need a mo. Anybody need a mo? Cool. Let's do this. Go to the next page, please. Alright, so these are some steps that you can graph the quadratics by hand. And it says create a table of values for the quadratic function by plugging in numbers for x, plot the points on the graph and carefully connect them, identify the solutions from the graph. And how would we know what the solutions are? When y equals 0. Good, take a point. Or when the graph crosses what? The x-axis. Good. Alright, so let's do this. Now, what I would suggest doing is out to the side, plugging in your numbers right here, and do a process column. So I'm going to write the function at the top. X squared minus 2x minus 3. And for the first one, everywhere I see an x, what am I going to plug in? A negative 3. And then we're going to get our y value. Oh. Alright, so we have negative 3 squared minus 2 times negative 3 minus 3. And we're going to work that out. So what's negative 3 squared? And what's negative 2 times negative 3? What's 9 plus 6? And what's 15 minus 3? down. Does everybody see how we got 12? We're just using order of operations. All right, let's go plug in -2. All right, what's -2 squared? And what's -2 times -2? 4 plus 4 is, and 8 minus 3 is? Awesome. Now, do you think it's always going to repeat when we plug in 0? Not necessarily. It depends on what's out here, right? So don't get that in your head that it's going to repeat at 0. You have to find where it starts to repeat. All right, so let's plug in -1. Work that out and someone tell me what you get. You got 0. 1 plus 2 minus 3. Yep. All right, let's plug in 0. Now, do you have to do the process column every time? No. This is just to help you in practice and make sure we understand where we're getting our numbers from. What are we going to get for this one? -3. Awesome. What? And at least whatever happened yesterday during first isn't happening again. Apparently a table flipped over. Alright, what did we get when we plugged in 1? Alright, so have we started repeating yet? Nope, so we have to keep going. Once it starts repeating, you can cheat and quit. Which is the only time I will ever tell you that. What did we get here? Alright, does it repeat there? So what's this next y value going to be? 0. Dun, dun, dun. Now, which one is our vertex? What note did we write down on the previous page? It's the coordinate that doesn't repeat. So which of those up there doesn't repeat? Because if we keep going, if we plugged in 4, what should we get? We should get 5. And if we plug in 5, what should we get? 12. So which one doesn't repeat? 1, -4. So this is your vertex. Now, looking at our t-table, how many roots do we have? And if you don't remember what roots are, look back at the first page. We have 2, right? Good. Take a point. And which 2 are the roots? All right, now, question. Do we have enough room on our coordinate plane right here to graph -3, 12? No, so we don't care about that one. We're going to graph the next one. So we're going to go left 2, up 1, 2, 3, 4, 5. Left 1, 0, 0, 1, 2, 3. Right 1, down 1, 2, 3, 4. Now, it starts to loop back around, so if I wanted to make it even, because that's going to drive me insane, because that's just the kind of person I am, what is my y value for 4 going to be? It's going to be the same as this one, right? Yeah, so that's all you have to do is you have to mirror it. Alright, so your solutions are -1, 0, and 3, 0. Love it when you guys pack up when I'm still teaching you. And your vertex is 1, -4. Is it a maximum or minimum? Minimum, because it's the lowest point. Alright, for homework, I want you to try 2, 3, and 4 without me. If you're feeling fancy and you want to move on to 5, you can.